Okay, so today we're going to continue our work with circles and we are going to actually start finding area of a circle. So make sure you're following along, make sure you're listening and filling in your notes as we go. So far we've talked about the different parts of a circle and we have found circumference. Like I said, today our focus is going to be on finding area. So the area is just the space on the inside. Let me grab a pen. On the inside of an object or shape. Okay, so area is written as, we want to report that as units squared. So if we have meters, it would be meters squared, or centimeters would be centimeters squared, yards squared, just units squared to the second power. And then we want to use the formula area equals pi times radius squared. So we're going to use this formula over here, and now we're going to be focusing on using our radius. Remember, our radius goes from the center of our circle out to any point on the circle. So it's that shorter line that goes out from the center. So every time we find area of a circle, we're going to use area equals pi times radius squared. There's really no easy way or really visual way to see this necessarily. It's just a formula that you're going to have to remember. So that's something that you want to keep in mind. You want to keep trying to remember it. And to help with that, I would suggest just writing that formula every time. So every time we have an area problem, we're going to write out A equals pi r squared. We're going to write that every time, and that should help us to remember the formula. So we're going to come down and do some practice together. Let me scroll down here. The first problem says a circle has a radius of 3.2 meters. Find the exact area in terms of pi, and then find the area using 3.14 for pi. So as we talked about, if we want to find it in exact terms of pi, that means we're not going to actually type it into the calculator or anything. We're going to use the symbol. So remember, area equals pi r squared. And then we're just going to plug in what we know. So we're going to do area equals pi. Like I said, we're not going to change that. We're not going to use 3.14 yet, but pi times our radius is 3.2. So we're going to do 3.2 squared. And remember, if we have an exponent of 2, or if we have a number squared, what that means is we are doing 3.2 times 3.2. So we're multiplying a number by itself. You can use a calculator for this. If you want to, if you're not sure where the squared button is on your calculator, feel free to come ask for help or come ask us, raise your hand, ask me, and I can come help you and show you where. But I don't know if you'll be able to see this. I'm going to hold it up. It is right here, and it's where it has the x squared, x to the second power. So the button on the calculator that you'll use is x to the second power. So when we are using our calculator, all we have to do is type in either 3.2 times 3.2 or 3.2 and that x squared button. So if we do that, we are going to get area equals pi times, and if we do 3.2 squared, we get 10.24. And you can leave it this way. You can leave pi times 10.24, or you can rewrite it so the numbers first. I just tend to do that. So you can rewrite it as area equals 10.24 pi. Okay. So then we're going to go ahead and we're going to do the same problem, but we're going to find area using 3.14 for pi. So we're going to actually do the calculation. So again, I'm going to write out my formula because I want to get in the habit and I want to remember my formula. So area equals pi times radius squared, or pi r squared. And then I'm just going to plug in. So my pi, we're going to use 3.14 times 3.2 squared. And again, I'm going to use I can use my exponent button on there. I can use my squared button on my calculator, or I can just multiply 3.2 times 3.2. What I would recommend if you're using a calculator, because some of you will use your Chromebook calculator and some will use an actual handheld calculator like this one, I would recommend doing the 3.2 squared first. So on your calculator, you're going to do 3.2 times 3.2 or 3.2 squared, and then multiply that times 3.14. When I calculate that, when I type it all in, I'm going to get an answer of 32.1536. And we want to make sure we include our units, and that is meters squared. So 32.1536 meters squared. All right, so we're going to scroll down and do a few more problems here to practice. Take a look at our next one. It says the distance from the epicenter of a particular earthquake to the outer edge was about 134 miles. To the nearest square mile, what is the area of intense shaking? And it says use 3.14 for pi. So we want to make sure we're using 3.14. We're not going to forget that. And then it also wants us to round to the nearest square mile. When we're rounding to the nearest square mile, that means we are actually going to round to the nearest whole number. So let's take a look at what we have. We want to, first, I think it's helpful to draw a picture. It helps us to see what they're telling us. So if we are measuring the distance from the epicenter, that means we're going to use a circle, and the center is going to be here. So the distance from the epicenter, which is right in the center, to a particular outer edge. So like if I just come from here to any edge, that was 134 miles. Well, if I look at what I just drew, that is my radius. So when I go to solve this, I have my radius is 134 miles. So I am going to write out my formula, and that is area equals pi r squared. And then I'm going to just fill it in. So I said I'm going to use 3.14 for pi. And my radius, we said, was 134. So times 134 squared. Okay. I'm going to do 134 squared on my calculator first. So either 134 times 134 or 134 to the second power. Then I'm going to multiply that by 3.14. When I do that, my answer is 56,381.84. But it did tell me to the nearest square mile, so I'm going to round that. So this is going to tell me that this is approximately 56,382. It's going to round up because if I look at what number is in my tens place, remember 5 and up, bump it up. So since it's over 5, it's an 8, it's going to bump up my 1 to a 2, and then I want to make sure I include miles squared. Okay, so let's take a look at practice number 3. The diameter of the eye of a hurricane was 30 miles. So the nearest square mile, what was the, and that got mixed in there, what was the area of the eye? All right, so we are going to draw a picture again. I'm going to draw my circle as best I can on here. And they told us that the diameter of the eye of the hurricane, so that means all the way across my circle, is going to be 30. All right, we want to again use 3.14 for pi. And it does say, again, to the nearest square mile, so I'm going to estimate to my nearest whole number. So when I go to solve this, again, I'm going to use area equals pi r squared. Okay, the problem here is I have diameter. My diameter equals 30. And I know that my radius is equal to diameter divided by 2. So I'm going to do 30 divided by 2, and that's going to give me 15. So my radius equals 15. Now I can take my radius and plug it right into my formula over here. So we are told to use 3.14 for pi, and I'm going to multiply that by 15 squared. Again, I want to use my calculator, and I want to do 15 squared first. So this is actually going to be 3.14 times 15 squared is 225. And when I do 3.14 times 225, I get 706.5. And again, I want to round that to the nearest square mile. So I look at what number is in my tenths place. It's a 5, and we know 5 and up, bump it up. So this is going to be approximately 707 miles squared. Okay, let's take a look at our last problem here. For number 4, we have, it's kind of multiple steps here, but we can work through this. It says, how many smaller circles do you need to equal the area of the larger circle? Okay, first of all, since we are talking area, we do want to find our radius because here we're given diameter for both circles. So the first thing I'm going to do is look at my bigger circle, which has a diameter of 12. That tells me that my radius is going to equal 6. And over here, I have a diameter of 4. So this radius is going to equal 2. So I'm going to start with my large circle, and I'm just going to find the area of each one. So my large circle, I'm going to do area equals pi r squared. And since I am going to compare the two, and I want to know how many could fit inside, I'm not going to use 3.14, and it doesn't tell us to use 3.14, so we're going to keep pi. So when I do this, I am going to plug in my r. I'm going to keep my symbol for pi, and my radius was 6. So times 6 to the second power, or 6 squared. 6 squared is 36. So my answer here is going to be 36 pi. So I'm going to also do the area of my small circle. And when I do that, I'm going to rewrite my formula again. Area equals pi times radius squared. And again, I'm going to plug in my radius. So I'm going to keep pi the same, just my symbol, and my radius is 2. So 2 to the second power, or 2 squared. So what I'm going to do, 2 times 2 is 4. This is going to give me 4 pi. So to find how many small circles are in the larger circle, we are going to divide. I'm going to do 36 pi divided by 4 pi. And when I do that, my pi basically cancel out. So I'm going to have pi divided by pi, which would just cancel out to be 1. So really I'm focusing on 36 divided by 4, which gives me 9. So what this tells me is 9 small circles fit inside or fit into the larger circle. So that is how we solve that one. Okay, so you are going to do some practice now. If you have any questions about this video, about these notes, or if you have any questions about the next activity, make sure you check in with me and let me know what you're struggling with or what you need.